Hello, welcome back to Cracking the Cryptic, and this is a fascinating looking puzzle by Rodrigo Mahu from Chile. I don't know if we've ever had a puzzle from Chile before. Well, I'm wearing Chilean colours, but that's just a coincidence. Yeah, that might just add to the family of countries covered by Cracking the Cryptic puzzles. Anyway. We'll look at that in a moment. Don't forget that on Patreon you can be playing the really quite approachable Sudoku hunt called Guess Again. And people have been really enjoying, well, a particular revelation in it that comes at the end of the first puzzle. And thank you very much to everybody who sent in a solution. Absolutely loads of correct four-letter word solutions. Well done. Now, that's on Patreon, along with loads of other stuff on Patreon. Of course, on the channel recently, we've had Simon's Solve of Dave Gorman's crossword, the Wordle shorts every day, in case you're interested in those. So that's the more wordy stuff, but lots of other content to do with Sudoku on Patreon as well. Simon's solves of a couple of Fistamafel puzzles last month, and mine of one. Loads going on. Do check it all out. The links under the video are where to find your way to everything we do. This is within the description field. There are links to Patreon, to the Discord site, to all our apps which you can buy, to the merchandise, and the catalogue of our past videos, which are numerous should you want more content to catch up on. Very few people have ever accused us of not doing enough content. So what's up with this puzzle then? Equal colour sums. Now we have to be a little careful about the rules and maybe read the example. So normal Sudoku rules apply. That's great. We expect that. Each continuous line segment of the same colour contained in a box adds to the same value. Now what's that saying? There is one sum value per colour. So for example, and the example is quite interesting. Let's work through it. Row 4, column 6, which is the only blue cell in box 5. So that must be the line. So that is the line total for each box for blue. And that is the same, therefore. The total of that cell is the same as the total of those three. They must add up to the same because that's one separate line segment in box 3. It's also the same as those two, and it's the same as those two. I mean, it's also the same as those three, and which ones did we miss? Those two and those two. So those all have the same sum, and it's the same as this digit. And that's how it works. I mean, it's a fascinating idea. No given digits, just these sort of 4 combined line shapes in the puzzle. I'm really impressed with the construction, just the look of it, the look and feel of this puzzle. Do give it a try. I don't know how long it's going to take. I wouldn't even, very hard to guess. So I'll guess a random half hour and we'll see how it goes. I don't know. Do give it a try on the link under the video. I'm going to start now. Let's get cracking. Let's get cracking with that blue thing, because you can see that both of these cells are represented by 3 digits elsewhere in the puzzle. So that blue, as we said in the rule introduction, is those 3 cells. That's the total. It's also those 3 cells. So it can, and those 3. So it can clearly be 3 cells. That means, and those 3 cell portions are all within the same box. They have to be at least 1, 2, 3. And that means each of these places has to be at least 6. Can't be any more than 9. So we also know that these 3 line pieces can't add up to more than 9. Now we don't know any such thing about the green. We can't, I was thinking that we could compute this box as 2 blues and 2 greens. But of course, not only is 45, the secret sum of the box, an odd number, so it can't be 2 blues and 2 greens, which would have to be even, but you've got this problem of these overlapping cells that are part green and part blue. So I guess we know that they add up to an odd number, because otherwise you can't make 2 blue and 2 green add up to 45, or 2 blue and 2 green plus those again, which is a weird way of looking at it. Anyway, that's not useful. Officially not useful. Right, here's something that is, I think. These 5 cells are the sum of 2 blue. Whatever the blue sum is, those 5 cells are the sum of 2 blue. They have to add up to at least 15, because there have to be 5 different digits in box 3. Now that means that blue multiplied by 2 is at least 15, and that means it's 16 or 18, and blue, the blue line segment, is 8 or 9. So if it was 8, this would have to be 1, 2, 3, 4, 6. That would have to be 2, 6. Can that work? This would be 1, 3, 4. There'd be a 1 there. It doesn't break immediately. Have a feeling blue will be 9, but it's nothing more than a limp feeling at the moment. This isn't getting us very far. Red line segment's always 3 or 2. We know they're 6 to 9. That's not very helpful. I don't think these shapes are useful. The way they join together just means that the overlaps matter. Without knowing what they are. That is blue plus green. That is blue plus green. Okay, something I thought when I first looked at this puzzle, and I haven't given another thought to since, is how much it looks like Ard van der Weitering's set theory extension. So after we got notified about the Fistemafel ring, Ard came up with a puzzle or two that involved 5 by 5 boxes sitting opposite 4 by 4 boxes. Yes, and okay, this might be interesting. This might well be interesting. The principle of those, I'm going to take out those bits. Okay, so I'm going to try and explain to you why this top right area, this top right thick L shape, adds up to 45 plus the bottom left thick L, thinner L shape. And it's probably best done. Okay, let's colour it all, just so I can explain this. Let's make that yellow and this purple. Let's make all of these cells and these cells blue. Right. And I think that helped. The way to look at this is the 5 boxes in which I've put colouring, they obviously are 5 sets of the digits 1 to 9. That is the rules of Sudoku. If you then... No, that's not the way to look at this at all. What is the way to prove that those 4 are the same? That this area is this area plus 40 plus 1 to 9. There is a way to prove it. Let me just think about this. Sorry, I'm going to get it right for you. Right, yes. Okay, let's do it a bit differently. So I'm going to uncolour those cells. So row 6 is a set of 1 to 9. Column 4 is a set of 1 to 9. So that's 2 sets of 1 to 9, although they overlap in this cell. Now, if you then take out the blue cells, you're left with these purple cells. So yeah, you take out from 2 sets of the digits 1 to 9, the blue cells, you're left with the purple cells. Now, let's instead consider these 3 boxes which involve the yellow cells and the blue cells. That's 3 sets of the digits 1 to 9. If you take out the blue cells again and 1 of this, you get the yellow cells. So 3 sets of 1 to 9 minus the blue cells and that once are the yellow cells. 2 sets of 1 to 9 minus the blue cells and that once are the purple cells. And therefore the difference between those two calculations is 1 set of the digits 1 to 9. And that means that whatever is in the purple cells are the same 7 digits as in the yellow cells plus the digits 1 to 9. And that, I think that is going to be useful here. And I think, why do I think that is going to be useful? Because we can do maths, because, right, in the yellow cells, we have 3 of these blue line segments, whether it's 8 or 9, we have 1 there, and 1 there. That's 3 blue. We also have 3 green, 1 in box 2, 1 in box 5, and 1 in box 6. So this is 3 blue and 3 green. And that, minus a set of the digits 1 to 9, which is 45, equals what is basically 3 purple. So I think that gives us an algebraic equation that we can divide through by 3. 3 green and 3 blue equals 3 purple plus 45. So we divide that all by 3, and it's the same as saying that 1 green and 1 blue equals 1 purple plus 15. Or sorry, 1 red is the line colour. 1 red plus 15 is the same as 1 green and 1 blue. Right, what does that mean? That means that a blue and a green minus, yes, red plus 15 equals blue and green. That's really interesting in box 3. Look, that is really interesting in box 3. Because what is the most red can be? It's 9. If that group of cells was 9 plus 15, it's 24. If that group of cells was 9 plus 15, it's 24. That's 48. Of course, that's counting these 2 cells twice, and that leaves them to be 3. And that's the only way you can do it. If you made red any less, if you made it 8, you'd have 23 plus 23 is 46, but you'd have to subtract 2 cells to get to 45. That just doesn't work. So that is an absolutely extraordinarily brilliant construction. And it is a maximum minimum thing, and we can rely on it. This becomes 9, this red line. That's a 9. Then this adds up to 24. This adds up to 24. Between them, all the lines add up to 48, but that's counting those 2 twice. They must be a 1-2 pair. We said they would add up to an odd number, and they do. Oh, there goes the drilling. Marvellous. So that is it. I'm sure this is right. Yeah, that is right. And look, 9 there gives us, instead of 8 or 9, gives us 8 on the blue. So now we know blue is 8. Blue and green together were 15 more than 9, which is 24. So green is 16. So, oh, well, we said when blue was 8, this is a 1, 2, 3, 4, 6 set. Sorry, I have the wrong cell highlighted. So that's 1, 2. Then we've got 3, 4, 6 here. But blue adds up to 8. So that's a 3, 4, 1 pair. Yes, obviously. This is a 6, 2 pair. Now the greens add up to 16. So we need another 15 here to go with the 1. Can't be 6, 9. That's 8, 7. And we're away. This is brilliant. Now we get a 5, 9, 2, 16 on the green. And that sort of confirms it. But we now know all the line totals. Green is 16. Red is 9. Blue is 8. So we need a 1 in this group of cells. That goes here. This is either 2, 5, or 3, 4. Red is 9, so we can add on to 2, 3, 4, or 5. We add on 4, 5, 6, or 7. Ah, it can't be a 4 because there's a 3, 4 pair looking at it. So that's reducing the options a bit. Green adds up to 16. So that's not a 5, or we'd have to have a 10 here. So that's reducing the options further. This is 9 or 8 now, I reckon. Now, what else? This is 8, but it can't be a 2, 6 pair because that cell can't be either of them. Ah, this one sees a 1 and a 3, so that's either 7 or 5 with 1 or 3 below it. Oh, look, where does 9 go in box 2? Oh, that's incredibly useful. 9 has to be in one of those cells because it's not in the cells we marked up. But that 9 rules out some of them. So now 9's on the green line, which adds up to 16 in the box. So that is 9, 1, 2, 4. Because 7 can only be made in 3 cells in one way. So we know where the 1 goes. That's got to be there. And we don't... Oh, that's not a 4 because of the 3, 4 pair. There is a 4 in one of these 2 cells, and that looks across here and makes it a 5. So suddenly box 1... Well, the lines in box 1 are done. That 7 looks back across here. Oh, actually, the 1 was looking straight at that as well. 2 has come out of those 2 and gone in there. This is a 6-3 pair. We know the order. And suddenly, this impossible puzzle is looking relatively doable. 7, 8 here. Yeah, they're in. Wow, we've got loads of rows 1, 2, 3 done. Now, this adds up to 9, and that does. That's 18. That's 21, 39. These 2 add up to 6. They're either 1, 5 or 2, 4. Oh, and this adds up to 16. Plus 6 is 22, 30, 39. Take it away from 45, as always. This is 1, 5 or 2, 4 as well. That means this is not a 1, 2, 6 sum. So it's either 2, 3, 4 or 1, 3, 5. Can't be 1, 2, 6 because this will need either a 1 or a 2 in it. Same's true here. 2, 3, 4 or 1, 3, 5. Definitely got a 3 in all of those cells. And actually that's not here. Oh, and these, look, there's a 1, 2, 4, 5 quad now. So these ones are 3, 6, and 7. Now these 2 add up to 8, but I don't know what they are. Oh, look, we can do the same trick with the 9s. 9 can't be there, so it's on this green. And that means it's a 9, 1, 2, 4 green. Again, that's beautiful. 9, 1 must be there. That's the 2, 4 pair. We've now used 1 and 2 in the box. This 8 must be 3, 5 again, just like up there. Vast amount of symmetry going on. That's not 3. 3 in the middle box is now, oops, here. That's not a 5. Okay, I haven't looked at this at all. Now, this is 16 without using 3 and 7. It's difficult. Okay, I've got 3, 6, 7, and 8 to place in this final column. That leaves, I suppose there are 6 permutations to give me a different digit there. I'm not thrilled about that. Oh, 3, 5, 2, 4, 1, 9. This is a 6, 7, 8 triple. What does that do? Not much. This box is very empty. Okay, I need to look at this line. Okay, let's think about this again. It doesn't have a 3 or a 7 in it. It adds up to 16. It can't miss out 1 or 2 because then it would have to be 4, 5, 7. That's not good. So there is either a 1 or a 2 in it and only one of them. So if there was a 1, we need another 15. It's 1, 6, 9. If there was a 2, It's 2 and another 14. Oh, bother, there are 2 ways of doing that. Okay, never mind about that. This has to have a 1 on it because it adds up to 8. So the 1 is in one of those 2 cells. Oh, this red adds up to 9, so we can't make that 7 or 8. If it's a 6, we're going 1, 2. If it's a 3, we could go 4, 2, or 1, 5, either way round. Oh, but that leaves fewer possibilities for this. This has to add up to 8, this line. So this is 7, 6, or 3. Now, if it's a 7, these have to add up to 9. 7, 3, 6. Is that right? Yeah. I think this has to be a 3, 6, 7 line. Because if you've got 3 or 6 there and 3, 6, or 7 there, 3, 6, 7 is the only way to make it up. So that's a 3, 6, 7. That is where 8 goes in the box. That's not 8. Hasn't resolved this finally, has it? Does that 8 help anything? Not really. 2, 4, 6 can't be there. Oh look, there's a 7, 8 pair. I could use uniqueness on that little set, but we don't like to do that because we like to prove our puzzles only have one solution, not just assume from the constructor that that's the case. We need a 2 down here, 3, 6, 7, 8. No, I don't think that 7, 8 pair helps at all. 2, 9. Right, where am I looking? What am I meant to be doing now? Look at this. 2, 6, 8 it sees. It also sees 3, 1, 9. So that's 4, 5, or 7. Oh, let's focus on this. This can't be 1 or 5. This can't be 2. This has to add up to 9. Then this has to add up to 9, which I haven't really looked at because there always seem to be... Ah, hang on though. This line is either 1, 2, 5 or 1, 3, 4. So this is 1, 2, 3, 4, 5, but it can't be 1 or 5. So that's 2, 3, or 4. To make it up to 9, this is 7, 6, or 5, but it can't be 6 because that's already in the column. So we take 3 out of there. 5 or 7 here. Oh, has that restricted this at all? 2, 1. This is either a 1, 5 pair or a 1, 3 pair. If it's 1, 3, the 3 is not there. So this is 1 or 5 as a result. Oh, and this makes 16 with a 1 or a 5. Well, that's quite limited. So it's either 1, 6, 9 or 5. Can't be 5, 6, 7, 4, or 3, 8. 5, 2, 9. 1, 6, 9 or 5, 2, 9. Now the key thing there is there's a 9 in it for definite. Therefore this is a 4. Wow, that's clever. 3, 7, 4. So does that get me anything? Yes, it places a 9 here, I reckon, in column 2. That's not a 4 anymore. If that was 5, 2, 9, this has to be a 1, and we get 6 and 8. If it's 1, 6, 9, then this is a 2, 5, 8 triple, which would have 2 here, 5 here, and again 8 here. This seems to be the only place for 8 in the column. Yes, if 8's not on that line, this is the only place for 8 in the column. So that's a 2, 6, 9 triple. That's not a 2. Ooh, it's either 5, 1, 2 This can't be a 5 anymore. Guess it could be. That's nonsense. Oh, come on, come on. We were going so well. Ground to a halt. Am I missing something along here? That's nearly a 1, 2, 3, 4, 5 quint. 8. 8 in this box has to be here. That's the only place it can be. That place is an 8 here. I mean, I'm getting these 8s. I don't think they do anything else. They just sit in the grid taking up some space, which is kind, I suppose. 9's here. 7 now. I suppose it could be there. Maybe I should be using this being... Oh, 7's in one of those two cells in this 3, 6, 7 set. So now 7 is in one of these two. And that must be a 7. And that is helpful. That sorts out this 6, 7 pair. 6, 1, 9, 3, 8. So 2, 4 or 7 here. One of them definitely is a 7. That can't be a 7, 9, 3, 8. This is from 2, 4 or 6. Oh, there's only one place for 1 in this row. I had not spotted that. That's big. That gets us 1 there. 5, 4, 2. So we've finished the central box. Finished box 2. That's a 1, 9 pair. That takes 1 off this 9 sum. So it's clearly 2, 3, 4. That's a 6, 5 pair. So the symmetry will end because this isn't going to be 2, 3, 4. In fact, we now know it doesn't have 4 or 2 in it. It's 1, 3, 5. So that's 3, 3. That is 1 or 5. Now, does that 3 doesn't look down into this, does it? There's a 1, 5 pair. I've known about that for a while. No good. Come on, what else is this doing? 7s, why aren't they more helpful? 3, 7, 4, 8. We've got this 2, 6, 9 pair. Oh, come on, this is, if that's 2, got 1, 5 pair. I can't see the way to disambiguate the rest. I think we only need 1 more deduction at this point. I'm confident. Right, now what I wasn't paying attention to earlier was that these included a 7 for sure. 6, 1, 2, 3, 5, 1, 3. There has to be, no, there doesn't have to be a 1 there. This could be 3, 4, 2. There's so many possibilities here still. Right. Just need to be methodical. That is 2, 4, 6 or 7 according to the column. 1, 9, 6 or 2 or 5, 2, 9. Oh, it can't be 5, 2, 9 because that would make this a 7 and that would need a 2 here. So it's 1, 6, 9. Right. There we go. That'll do it. We will finish now, he says wildly overconfidently. We get a 1 there, 5 and 1. The 1 fixes 9 and 1. That means this can't be a 1 in this 9 sum. It's either 4, 3, 2 or 5, 3. This can't be a 6 anymore. That's a 3. This is 1 or 2. That's not. There's a 2, 4 pair, so that is actually 1. We can finish off this. 7 and 6. This is a 5. All those lines are right. That does 6 and 5. There must be a 6, 5 pair at the beginning of row 7 in those two cells. So this is 2, this is 7, that's all working. This is 4. There's a 7 here. We can do these numbers on the right. 5, 9. That's become a 7. which fixes the triple. I was right that it all comes apart with that one more deduction, thank goodness. What a clever puzzle though, what a really intricate piece of work. Lovely stuff from Rodrigo here. 4 there, that can't be a 4, that can't be a 4. Got 4 and 3 to place in box 7. Fixes 2 and 3. We get a 2 and a 4 and just this 6-2 pair left. There we go. What a brilliant puzzle. Equal colour sums. A little bit of set theory, but there might be other ways through that, but it seemed to me that the set theory stuff was important. So I'll be very interested in the comments today. I think that's a really clever puzzle. Obviously, sometimes any use of set theory, if it is necessary, is a bit frustrating for people who are kind of using regular Sudoku rules and looking for genuinely approachable or quite approachable techniques, because it's a little tough and it really helps to have experience. I know that, but that's a brilliantly clever puzzle, and I hope you enjoyed it. Thank you, as always, for watching us on the channel, and hope to see you soon. Bye for now.